All right, physics episode 4 in preparation for the big exam. This is going to be part 1 going over kinematics, which, for anyone that is unfamiliar with physics, kinematics is basically the study of how things move, basically, and mainly for kinematics, doing math, being able to calculate, say, for example, if you throw a ball at how fast, how long it will take to get to a certain point, or when it will hit the floor, and calculating how gravity affects all of that. So it's a lot of formulas that you need to understand. It's a lot of practice problems that you have to do. In and of itself, it's not too difficult to understand. It's just um, doing a lot of practice problems. So when you're actually asked it on an exam question, you know how to do it. And that only comes through practice. So you need to review material and you can't just wing it when you take the test, that's for sure, or else you will fail. So, all right. Oh, we have another typical test question. First thing starting off. The variables y and x are related by a power law function y equals ax to the b. Based on the graph at the right, what are a and b? All right, so this is a log of x and a log of y graph. And if you remember yesterday, we talked about how um, we talked about how when you have a power law graph, you would have a linear line if it's just log x and log y. So if we look at this, based on the graph to the right, what are a and b? So this is a power law function, and this is a linear graph. So, so if I remember correctly, our slope doesn't change. So it looks here, um, our slope, which would be b, right? It looks like it's linear, which is why I'm confused. So what are a and b? Hmm. So if we look over here, we say so slope is rise over run, right? So if it runs from x equals 0 to say 4, right? So our run here goes from 0 to 4, and our rise goes from about 1 to 8. So our rise here is 8, our run is 4, rise over 1, our slope is 2. So B, our slope should be 2, right? And then our constant A would be the y-intercept, right? But so you see here when B is 0 or when X is 0, right? We know that Y is 1. But since this is a logarithmic graph, the slope is going to stay the same, but A should not be 1. I believe it should be like log of 1 or inverse log of 1. And log of 1 is 0. So, or what's inverse log of 1? The inverse log of 1 is 0. All right, so if this were a regular function, right? What's log of 0? That doesn't exist. If this were a regular function, it would be d. But from all my troubles of doing practice problems yesterday, I'm going to say it's c. I don't really know, but we're going to figure out. Oh, I got it right. Cool. So I did get it right. Interestingly. And the logic here is right because even with a logarithmic graph, your slope is going to stay the same here, right? We got that right. The slope was right. Now, for getting to that 10, it looks like they said log of A, you set log of A equal to 1. So I'm assuming that log of 10 would be 1. So, hmm, gotcha. I'm still kind of confused on like, because it's been so long since I've done like high school algebra or whatever. So, how are you able to convert logarithmic back to whatever? So I'm going to write down a formula here. So if we know log of a is equal to 1, so I'll just say log of x is equal to y, some given y, right? So you set, is that it? So does that mean x equals 10 to the y? Is that right? So for example, log of 10 equals 1, right? And 10 raised to the 1 power equals 10. So my math will be correct. So my formula is x equals 10 to the y power if log of x equals log of y. So if that's right, log of 5, which is equal to 0.69, so that means that 10 to the 0.69 power should be equal to 5. And it is. So I was right about that. Cool. So now you know how to do it. Sweet. Kinematics. A mathematical way of describing how objects are moving in space, not outer space and time. Three types of space we think about: three-dimensional, two-dimensional, one-dimensional. In a mathematical sense, we treat time as an extra dimension. All right, cool. Position. An object's position expresses its location with respect to its origin of a coordinate system or another point of reference. So we see here, this is a tree, right? So this would be considered 0 meters, and anything right of the tree is considered 10 meters, and anything left of the tree is considered negative. So you see this Rashad is at positive 10 meters, Bryce is at negative 20 meters. And yeah, that's position. Vectors and scalars. An object's position is an example of a vector quantity. A vector quantity has both magnitude and direction. Quantities without a direction are called scalars. Scalars have positive or negative values. So, yeah, so a vector quantity has a magnitude and a direction. So, if I said that Michael is traveling at 10 meters per second west, that is a vector because I've given a magnitude 10 meters per second and a direction. But if I say Mike is just traveling at 10 meters per second, that is a scalar quantity because I've only told you the speed or the velocity. I haven't told you what direction he's going in. So magnitude and direction is a vector. Scalar is just one of those, right? So pretty easy to understand there. Position. We can represent Bryce position with position vectors. Position vectors are drawn from the origin of the coordinate system. We represent position vectors with the symbol X with the little arrow above it. Okay, cool. An object's displacement is described as a change in an object's position and is denoted by delta x. So this little triangle here is known as delta. For any of you kids watching this, that maybe if you do a calculus class ever, this little triangle here is known as delta x. So let me write down here. Delta x with a little arrow equals displacement. Pretty straightforward so far. Haven't made you want to pull your brains out yet. I'm sure we'll get there. You guys like my orange jacket, bro? I'm at work, so got this jacket when I for my first ever 911 EMS job, bro, and it low key like drips hard. It's like reflective. It looked like a highlighter for real. Generally speaking, subscript F refers to final, where subscript I refers to initial. So where it's saying delta X equals, so X just refer to X's position. So delta X means change in position. So literally change in position is your final position minus your initial position, right? So let's say I start at zero point 0.0 meters and say I travel 10 meters, right? My You already know I travel 10 meters, so delta X is 10 meters, right? But my initial position was 0 minus 10. So 10 minus 0, X final minus X initial is equal to displacement, which is 10 meters per second, right? So um, delta X equals delta X final, well, not delta X final versus X initial. And that's another thing to pay attention to in a lot of these problems, because a lot of these equations or a lot of the formulas for kinematics are very specific on final versus initial, right? So there might be an equation, right? And it will ask you to say solve a kinematics problem where it says calculate how far an object travels over how many seconds, right? And that formula might say put using VF or velocity final. So if you accidentally use the initial velocity to calculate it, you're going to mess up the problem. So that's something important to pay attention to. Typical test question. Suppose that is Rashid an Indian name? I think it is. Bro, I didn't want to say anything racist, but it was like funny because like I was thinking about how like migrants have just like invaded the UK, and now like Rashid has invaded my physics lecture in America, in North Carolina, bro. They gotta use like Michael. Like, this is America, bro. Like Rashid. Is Rashid a black man's name? I don't know. Suppose that Rashid moves his initial location to his final location. What's the vectors below? Best Rashid's place. Okay. So this is Rashid, right? So he starts at 10 meters right of the tree, and he goes 10 meters, or not 10 meters, 15 meters left of the tree. So X initial is 10 meters, X final is negative 15. So obviously, using your brain, you know he traveled 25 meters to the left. So using our little equation, X final, negative 15 minus initial position, which is 10, equals negative 25. So the displacement vector is going to be negative 25 meters to the left, right? So if we're going in increments of 5, we would need to have 5 boxes. So it looks like 1, 2, 3, 4, 5. C is the only correct answer here. And that's correct. Pretty straightforward so far. This is elementary stuff, bro. I was talking to so my best friend, his name's Nathan Guido, and I remember he has an older brother, and his name Nick, and Nick's cool. And I remember I was doing like a beginner statistics class. It was like a year and a half ago, like right when I turned 19. It was the beginning of my sophomore year of university. And I sent him a practice problem of me just doing something like this for a statistics class, and he was just like, "It's easy elementary shit, bro." And I was like, "Bro, I fucking need it." Like, college is hard, bro. Life is hard. Like, if I could take an exam with questions like this, Like, I could just 4.0 everything, but life never quite works like this. But you know what? It's all about practice, right? The more you practice at things, the easier they get and the easier they are to understand. But you have to be the guy and you got to put in that work first. Shown below are four different pairs of initial and final vectors, in which case is the displacement to the left. So, just a general rule of thumb, displacement to the right is positive, displacement to the left is negative, right? So just think of that in that sense. So it says which case is a displacement to the left. So a displacement to the left, we would want the x final to be less than the x initial. Because if the x final is less than the initial, right, we know that they've gone to the left. So x initial, -2 to, that means they moved right to 1. That's wrong. X initial is -3. They moved right to -2. That's wrong. X initial is -4. They move right to 0. That's wrong. X initial is 3. They move left to 1. So D is the only one where the displacement would be to the left. So that'll be right. All right, position versus time graphs. At t equals 0, Natalie is at x equals -2, right? So that's where Natalie is at time equals 0 seconds. I'm at 0 seconds, or me, and Alyssa is at 3. Man, even though the women are running from me, even in the physics questions. Come on, bro. Let's plot this on a position versus time graph. All right. It looks like Natalie walks to the right after 7 seconds. So yeah, it looks like we plotted Natalie's movement over a time graph. So it um, looks like she, for the first 2 seconds she's staying still, and then from 2 seconds to 7 seconds, it looks like she's traveling towards the right, and then she stays still for 2 seconds. The slope of the line is 0 when Natalie is standing at the position point. The slope of the line is 0 when Natalie is standing at the same position. The slope is positive when Natalie's walking. So yeah, so you can see this is a position versus time graph. When she's staying stagnant, right, the slope of the line is 0. And when she's moving, there is a slope. And then when she stops again, the slope is 0. The slope of the line is given by the change in position divided by the change in time. So yeah, so if you remember from high school pre-calculus, your slope is just your rise over your run. So basically rise, change in y position divided by run, change in x position, right? So in this situation, it's delta x is on the y axis and delta t is on the x axis. So that would just be your slope, right? And that's not a general rule of thumb. Like slope doesn't always mean delta x divided by delta t. It's just literally rise over run. That's the thing that's so frustrating about some of these university lectures, bro, and like some of the because I remember in high school I did AP Chem when I was like 17 years old. I did a lot of like self studying because I was like a really smart kid. Like I studied a lot. That was my pretty much all that I did when I was in high school. And then like a lot of professors and teachers will teach things and they'll try to explain them in ways that aren't really the best way in which you could understand it. And like you can go on YouTube and someone will explain it in a totally different way and it'll make a lot more sense. But they'll teach you something in class and just give you a formula that says slope equals delta x over delta t, and then they'll ask you for the slope on another graph and you'll be confused because they told you that slope, they literally told you that this is the formula for slope. So you get confused the next time they ask you for the slope. So I mean, I don't know. I want to make a lot of videos like obviously like I want to be a doctor, right? Like I'm nearly done with paramedic class. I'm doing these pre-med prerequisites. Like I'm almost done. I got an associate's degree. Literally all I have to do is just grind through some of these classes and take the MCAT, and my ticket to medical school should be punched for real. But obviously I want to finish my paramedic class and then get really get a maybe a really high paying contract job as a paramedic and do that during like my gap year as I apply and stack some cash, bro. But like I want to make a lot of content like teaching this stuff, right? Because it's a lot of work, right? Like it's definitely not easy. It takes a lot of time, but I want to be really good at like breaking stuff down in like a way of which like stupid people could understand, right? Like I feel like a lot of people when they try to teach stuff, they try to explain stuff, they try to sound like they're really smart or really educated, but like that's really not the best way to teach someone. Like if you can really dumb something down and explain it to like a kindergartner, then that's when you become very competent at a subject, truthfully. But all right, position versus time graph slope. Velocity is represented by the slope on the position versus time graph. The slope of the line is given by the chains of position. All right, so velocity. Think of think of velocity as how fast something is moving. So velocity and speed aren't really the same thing. You could think of speed as velocity. It's just we talked about scalars and vectors, right? Velocity is the vector quantity of speed. So speed is a scalar quantity. It's just saying like you're driving at 65 miles per hour, right? That's speed, right? But velocity would say 65 miles per hour or negative 65 miles per hour. So velocity tells you the speed in whatever direction, right? Because as I've told you, let's say if someone is going towards the negative direction, they're moving toward the left, their velocity is technically negative, right? But that doesn't mean that they're necessarily slowing down, right? They're just moving in the opposite direction. So if you want to find the velocity of something, it's just the slope, right? So in calculus, right, you have these things. If any of you take a calculus class, you have these things called integrals, right? So basically, calculus, you basically like it's been like 3 years, bro. Over 3 years. Jesus. It was like 16. But you have these things called like integrals, right? And you're basically just using the slope to calculate the graph of something else, right? So obviously, if I were to draw a velocity of time graph versus, this Natalie person moving, it would look different. But just by looking at the graph, I can kind of already figure out what her velocity is. So this is saying if you want to find her velocity over whatever interval, looking at the position graph, you just look at the slope, right? And if I gave you a velocity versus time graph and you wanted to find her acceleration, you would do the same thing. Because I haven't talked about acceleration yet. But you have position, and velocity is basically the integral of position, and acceleration is the integral of velocity, I believe. I know it has something to do like that. But as you can see here on this position versus time graph, the slope is zero. Like she's not moving, right? So she's standing still. Therefore, her velocity is 0 meters per second. She's not moving in either direction. And as you can see here, she has a positive slope. So she has a positive velocity, right? So she's moving at a positive however many meters per second in the right direction. If this slope were negative, we would say that she's moving negative x meters per second in the left direction, right? And then as she stops, the slope becomes zero again. And that's how you know that her velocity is 0 meters per second. But if we just wanted to find her velocity, we could literally calculate just the slope of this position graph and we could find that velocity. So average velocity of an object is determined by dividing the displacement of the object by the time interval during which the displacement occurs. So if you want to, displacement on distance. Yeah, so let's say, for example, if I told you I went around a walk on the park and, I walked 10 feet this way and I walked 10 feet that way and I walked 20 feet this way, and then I walked another 10 feet this way, right? I basically just kind of came around in a circle, right? So my displacement, you could say, would be like zero, but obviously the total distance traveled, I've gone on this long walk, right? So say I could have walked maybe a mile. Like let's say you go on a walk and you walk a mile around your neighborhood and you come back to your house. Your total displacement is zero because over that trip, your displacement from the beginning is zero. You're at the exact same place you started. but obviously your displacement is different. So that's why they put it in this little note here. Displacement is not distance. And if you want to solve the average velocity, you would do initial position minus no final position minus initial position divided by time final divided by time initial, which is also equal to delta x divided by delta time. And it'll give you the average velocity over the entire trip. Over the entire trip. Let's say, for example, you walk a mile around your neighborhood and you come back to your house. Obviously, you weren't going at 0 meters per second, but your average velocity would be zero because you're in the exact same place you started. That's another thing, man. Take action with your goals in life, bro. Like, like if you have an idea to do something, like you have some chores you want to do, or like you have some business idea that you're just kind of thinking about doing, just go ahead and do it. Because literally, a majority of people, probably, yeah, over 50% of people are literally going to be in the exact same spot they are right now, a year from now, or worse. And that's probably like statistically likely. So don't be like most people, man. Try your best. Try to do new things every single day. Make content, be a good person, treat others with respect. You know, treating others with respect and being kind won't necessarily um, guarantee that will be reciprocated, but it's always better to walk through the world being a good person and keeping your honor and keeping your head held high. That helps you sleep a lot better at night, in my opinion. I should write that down. Velocity average equal to delta x divided by delta t. Cool. Yeah, we describe the average speed of an object as the ratio of the distance traveled to the time taken to travel that distance. So average speed equals distance traveled divided by time. So all quantities in the above are scalar quantities. Yeah. So speed is scalar, velocity is vector. Interpreting position versus time graph. Yeah, so identify where the slope is positive, where the slope is negative, and where the slope is zero. Identify. Is this asking me a question? Yeah, it kind of is. All right. So, at which of the following times does the object have the greatest speed? So, the greatest speed or the greatest velocity, this is a position versus time graph, remember? So, obviously, when the slope is the biggest, is going to be when it's moving the fastest, right? So, here you can see the slope is the steepest, right? Even though it's moving towards the left in the negative direction, it's still the greatest speed. So, if the question was asking, when is the greatest speed? It's not going to be one because one is moving, right? But it's not as steep as a slope is over here. And obviously, three, it's not moving at all because slope is zero. And at seven, slope is zero, so it's not moving. So, correct answer here would be C, 5 seconds. Yep, that's correct. Here's a graph of position of the right. Which of the graphs below shows the object's velocity versus time, right? So as I mentioned earlier, velocity is kind of just think of it as the integral of the position versus time graph. So this is a velocity graph, right? So this is someone walking, right? And as you can see, it's a straight position versus time graph. So they're walking at the exact same speed over this 2 second interval. Their speed isn't changing. So if their speed or velocity is changing over this interval, they have what's called a constant velocity. So, like when you look at the graph here, the velocity would just be a straight line. So, for A, we know this is wrong because this is saying that the velocity is changing over the first 2 seconds. Well, we can see the velocity isn't changing, it's constant, right? And then obviously we already know over 2 to 4 seconds, velocity should be zero. Over 6 to 7 seconds, 6, 7, bro. Velocity should be 0 seconds, right? So we want to find the graph where we know that, all right, over this second, over the first 2 seconds, it should be a constant positive velocity. Over this interval, it should be a constant negative velocity, and over these intervals, the velocity should be zero. So if we really look at the graph here, B is the only one that makes sense. So we see, yep, first 2 seconds, velocity is constant, positive. Over these intervals, it's zero, and over this interval, it's constant, but it's constant in the negative direction, right? And obviously, this is -1 meters per second, and this is zero point 0.5 meters per second. So technically, over this interval is when it's moving the fastest, which is what we said earlier. So the correct answer here would be B. Yeah, that's right. All right, what is the magnitude of the object's displacement? Right? So, magnitude of the object's displacement. So, as I told you earlier, um, displacement isn't the same as distance traveled. So, we want to find out um, where they went um, in proportion to where they started. Right? So, isn't there what was it? Displacement is equal to final position minus initial position, right? So we see here initial position is 0 meters, final position is -1. So it looks like we said final is -1 minus 0 initial position. The magnitude of the displacement should be 1 meter, specifically -1 meter, but it looks like B here will be the correct answer. Yep, that's right. The displacement can also be determined by the area under the curve. So, so yeah, I guess if you wanted to also calculate the displacement, you could do this. So, say for example, we said over here the displacement was 1 meter. So, if you do the velocity versus time graph, calculating the area under the curve will give you that displacement. So, over here we can calculate the area, and area is just like one side multiplied by other side. So this would be 2 multiplied by zero point 0.5. So this area here would be +1, and this area here would be -1 multiplied by 2, which will be -2. And if you add those together, you get -1, which would give you the total displacement. So if you want to just keep that as a general rule of thumb, total displacement, let's write this down. Total displacement is equal to area under the curve on velocity versus time graph. Oh, I'm getting tired of talking, dude. It's nearly midnight, bro. I'm up grinding again. Like I always do, for real. Life never stops. Gotta keep it pushing. Changing velocity. Below is a position versus time graph where the slope is different at every point. When the slope is not constant, the velocity must be changing. All right, so we said earlier, right, on a position versus time graph, if the slope is just linear, like it's just a straight line, we know it's a constant velocity, right? But here we know that the velocity is changing. So it's accelerating and decelerating. So right here, like this is a position versus time graph. So right here, position is 0, and then it looks like they speed up really fast and then they slow down until they eventually get back to 0. So if we take the slope right here, we know it's a really steep straight line. And if we take the slope right here, we know it's a really short steep line. It's a very short line. It's not really steep at all. So it starts off at a really fast velocity, and the slope is gradually getting closer and closer to 0. So this would be basically a graph that starts off as zero. Um, the velocity starts off as zero, ends at zero, but then it rapidly accelerates really quickly. But the entire time it's moving, it's slowing down until eventually it stops. But we know that because it's a changing line, the slope is changing, and we can kind of draw a little line here at each of the little points, and we can like know what the velocity is. So like right here at the very start, the slope is basically just a really, really straight upward pointing line. So we know the velocity will be the fastest at that moment. Yeah, so the tangent line, that's kind of what I was talking about and just explaining there. So the velocity at an instant time is given by the slope at that point in time. So in calculus speak, instantaneous velocity is given by the derivative. Yeah, so that's the word I was looking for. In calculus, there are integrals and there are derivatives. I'm sorry. So if you take a position versus time graph, the derivative of that graph is the velocity, and the derivative of the velocity graph is the acceleration. You're gonna have to take a calculus class to learn more about derivatives because it's been like 4 years. I don't remember how to calculate them or do them. But yeah. So yeah. So yeah, I think this is basically saying that the velocity is just the derivative graph of position over time. Which I don't know why they're telling you this, because it's a basic physics class, and probably a majority of people in this class haven't done calculus. So I don't know why they're talking about freaking calculus in here, bro. It's not fair to anyone else. All right, typical test question. At which point in times is Keisha moving the fastest? All right, Keisha. Cool, cool, cool. What time is she moving the fastest? So this is a position versus time graph. We know at say about, so we just got to look at where is the slope the steepest. So right here, the slope is basically zero. It's a straight line. But right about, in here, the slope is the steepest. So I would say maybe like right here, the slope is the steepest. So at what point is she moving the fastest? So it's obviously not one, it's not three. Five and six, I would say six is a little bit steeper than five. So I'll go with D. So that's right. Cool. All right. Which of the following graph best represents Keisha's velocity versus time? So as you see here, all right. So here, she's always moving towards the negative direction. So her velocity is always negative. So the velocity versus time graph should always be negative. So that already disqualifies A and C. So we already know B and D is the correct answer. And the velocity isn't constant. Remember, it's changing. It's getting more fast in the negative direction. So the velocity starts off as zero and it's constantly increasing in the negative direction. So D will be the only correct answer. Cool. That's right. I'm on a roll with these kinematics problem, bro. I mean, with in the previous episodes I did yesterday, episode 1 and 2, I was struggling with the math, but that's only because it's been like years since I've ever had to use any of this stuff. But like these problems are kind of just like more of like conceptual. Do you understand it? So bro, I'm telling you, maybe I gotta review my math, man. That'll be the only thing that'll mess me up on this test in 3 days. And at midnight in 9 minutes, it'll be 2 days. So I have like 57 hours to study for this test. So it's good. So I gotta lock in, dog. Um, shoot. All right. So at t equals 6 seconds, is the speed of an object one equal to or greater? All right. So as you can see, obviously this is position versus time graph, and both of these objects have constant velocity because it's a straight line. But all right. So yeah. So both of these objects have constant velocities, right? It's just that object two starts further ahead and is moving slower, and object one starts further behind and is moving faster, right? So if we take the slope here, objects one slope is still greater than objects two, and they just meet at time equals 6. So at t equals 6, is the speed of object one greater than, less than, or equal to? I'm gonna say it should be greater. Velocity should be greater, but it's saying speed. So if it wants to, it should be greater than. Yeah, it is greater than. That's right. Cool, cool, cool. Typical question. Elise is very worried. She paces back and forth, producing the position versus time graph shown below. Find her average velocity and average speed from t equals 0 to t equals 4. So as we know, average velocity would be displacement, right? Um, so we see she starts at x equals 4 and she ends at x equals 1. So over a 4-second period, she goes 3 meters, right? So if we take um, the displacement in meters, which is 3, divided by the displacement in time, that'd be 3 divided by 4, which would be 0.75. But remember, she's going from x equals 4 to x equals 1. So she's moving towards the left. So the velocity would be negative. So her average velocity would be negative 0.75. Remember, speed is the scalar quantity of velocity. So it would just be 0.75. So correct answer would be A. Is that right? No, I wasn't right. I was not right. So this is saying define the average velocity. The average velocity, yeah, you get negative 0.75, and then note the average speed. Oh, so they're taking, so to calculate the average speed, they're legitimately, all right. So for average speed, they're legit adding up the total displacement and dividing that by time, right? So all right, so all right, cool. So yeah, so they're legit saying she traveled 2 meters here, 1 meter here, and then 2 meters here. So they're saying she traveled 5 meters over 4 seconds, which would get you to 1.25. So I'm guessing the correct answer here would be B instead. All right. So as a general rule of thumb, what is it? We said, yeah, average velocity, average velocity is displacement divided by time. Average speed is basically the distance traveled of all intervals, right? So it doesn't matter if it's positive or negative. It's literally the average speed is the distance traveled of all intervals added together regardless of being, I'm going to put in parentheses, regardless of being, I'm writing out positive versus negative instead of actually just putting out a plus or minus sign. Plus or minus divided by time. I need to like get I already have a tripod, but I'm at work right now, so it'd be weird to like bring my tripod into work. I'm on night shift, night watch, night EMS watch, where I sit here and do my homework and wait for someone to call me on the radio. Pretty cool gig. Yeah, I need to like get like I need to put like my tripod over my get my phone and put that over like the pieces of paper. So like as I'm writing, like I can have that record what I'm writing, and then the webcam will record my face and like the PowerPoint what I'm showing, and then I can get my virtual assistants and editors to like clip it up and make like really cool edits and putting it all together using CapCut and stuff that I don't really understand, and they can like put all of it together. And then I think that would be like really good for like making content and like tutoring in the future. Especially I get more into like MCAT and like teaching medical stuff. I think that'll be pretty helpful. But yeah, that was kinematics lecture one. I definitely did a lot better with the questions on this episode than in the previous ones I did last night. I think yesterday I have still a lot of like math that I need to look into and try to understand.